from the reservoir, we are looking to the well bore. Now coming to the well head now, because this is the place where we can actually see every other thing I've been talking about is happening subsurface. This comes to surface now. Now, the fluids will arrive at the what? At the wellhead. And this wellhead is what we call our Christmas tree. And we know that the Christmas tree is a collection of valves. And these valves are for control and for safety, for control and for safety. And this Christmas tree has some key components that are attached to them. I've been able to see some of these wellhead components through visit to some sites, and the PTI has an example of this wellhead. So you see the wellheads and they are just looking beautiful, not like our typical Christmas tree that we have at home for Christmas festive period, but something like that, usually green in color also. And there, some of the valves are very important. In fact, all the valves found on a Christmas tree are very much important and vital if you want to optimize your production. So we have the master valve, main isolation is the main isolation valve. You have the wing valve, controls the flow to process line. You have the swab valve for access for wire line or intervention or emergency situations. We use the swab valve. Then just after these valves is one important feature that aids production. In fact, without this, I don't think that production would be complete. It's a very critical variable, and that is our choke. The choke now is what controls our flow rate. Now, controlling flow rate in the sense that you can either increase flow or reduce flow. So it is a management. In fact, they call it in optimization, when you're looking at optimizing production, they call it choke management. So it is one of the optimization tools, choke management, because when you tighten the choke, when it's too tight, then you kill the well. Meaning I've shut off the well for production. I'm killing the well when the well is too when it's too tight. And if that be the case, then why not just leave the choke fully open? If this is where I'm controlling flow, and as production engineers, I want to maximize production and I want to produce everything, because if I open the choke, meaning I'm going to be producing more fluid will be coming out. So why don't I leave everything open? Why not allow everything come out? So won't I be proud of myself if I'm supposed to spend 50 years in a well, and because I opened my choke very well, I'm spending 25 of that? Won't I be commended or not? So why are we not going to open the choke fully? And this is where choke management comes in, because as a production engineer, able to optimize production, you must be able to regulate your choke very well. And if you open the choke fully, I said uncontrolled flow can lead to catastrophic failure mechanism. When you open the choke very well, you're going to have excessive drawdown. There's going to be sand production. You're going to be having fines migration, because what is happening there is that the bottom hole pressure becomes what high when you open the choke fully. And at this point in time, there can be accelerated sand production. There will be fines migration. There will be formation damage. You're going to have rapid reservoir pressure decline. And our pressure is something that should be managed throughout the life of the well. Pressure is one of the energy boosts that actually brings this fluid to the surface. So you don't want it to decline. You want to be able to manage the pressure so that there won't be any early breakthrough, either gas breakthrough early enough or water breakthrough. So you want to manage your pressure. So opening the choke fully would lead to rapid reservoir pressure decline. high velocities, which can also lead to what? Pipe erosion. Your tubing, your choke, your flow lines, once the choke is opened fully, there can be erosion of your equipment. Now, opening the choke also can also lead to unstable flow. So you can experience slugging or liquid loading, where you have gas inside your traveling alongside your liquid in an ununiform manner. Let me put it that way, in an ununiform manner. Then you're going to also have either water cooling, which is premature, what we call our premature water or gas breakthrough in heterogeneous reservoir. So either you're going to get water arriving first or gas arriving first. That's because they decided to open the choke. So it must be managed. So instead, we come in and use choke management to maintain stable and optimal rate. Again, one of the tools that is used or that can be used to manage this situation is also the use of this nodal analysis. So pressure loss across the entire system can be studied and managed at each node. So what nodal analysis will do here is divide the pressure losses across all the nodes now being each point of our production system, where we have our reservoir, we have our wellbore. So each of those things, we call them the nodes. The pressures are divided across each of those nodes and managed there. So engineers try to identify where is the point at which the largest pressure drop would occur, and they also carry out test sensitivities there. Test sensitivities by trying out different tubing size, arranging the choke setting, and artificial lift. Also, another tool that can come in play here are some of our modeling tools. Yes, most of our schools are still trying to acquire these tools, but we have some professional that organizes trainings and workshops where we can actually get to learn some of these softwares that are being used. Prosper is one of those software that can enable people to learn about the well and system modeling. Then GAP is also one other one that does network optimization. Okay, so most times a well can show declining production. Increasing the choke size may look as if it's boosting production rates, but that can be a temporary situation, because you already know now that if I'm experiencing a decline, it is not so important to say I should increase my choke size, because it can lead to sand production, erosion, and instability. So what we need to do is to be guided by our nodal analysis and sensitivity test to be able to choose the kind of size that would give us, that's choosing a stable size of choke that would be able to extend the well of the life and also avoid costly walkover operation. So basically, as I'm touching on each of the systems, I'm also giving recommendations on how we can optimize production in each of those systems. So basically, nodal analysis has to do with finding the bottlenecks by dividing the entire system, the reservoir to the wellbore to the tubing, the wellhead, the flow line, into different nodes and treating each of them as nodes. So when you identify the largest pressure drops where the bottleneck occurs, you run test sensitivities, or you employ the use of common software to help you. So you have Prosper, you have GAP, you have sensitivity analysis that will help you evaluate your tubing size, your choke setting, or artificial lift impact. Okay, then the next point of our production system. Now, we're trying to compress everything. These are actually standalone topics in production engineering. That's why I said in my school, we do it from year 3 to year 5. We break down each of these systems into topics they are being treated. So forgive the fact that we are trying to rush everything and talk about them in 40 minutes. So basically, our surface facilities are talking about what can actually give us efficient phase separation. So I tell people, as much as we are producing different phases of matter from the subsurface, not everything is important to us. I'm producing water, but I really don't need the water I'm producing along with the oil I'm producing and the gas. So my ability to be able to separate them and get my to efficiently separate them and get the phase that matters the most to me is optimizing my production. And separation operates by gravity alone and density. So we have gravity separation principle, which tells us that separation is driven by what? Difference in density between the phases. So your ability to design your separator in such a way that you can achieve maximum separation becomes what's key at this point in time. So we know we have different type of separators, but the two governing factors or two things that are very much important to us is the gas capacity and the liquid capacity in any of the separators we have to use. So
yeah, Engineer Praise, sorry, you just have like 10 minutes more.
Okay, let me try and wrap up. Okay, so on the size separators, when we look at optimization challenges that can occur in our surface facilities, we're looking at undersized separator. If you have to use an undersized separator, what could you encounter? You may likely encounter things like poor separation efficiency, carryover, meaning gas is carried over in your liquid phase or liquid is carried over in your gas phase, and that can cause slugging and different problems in your separators. You can have off-spec export because there's always a requirement when you are to export these things. You can have foaming and downstream issue or overloading. Also, high liquid level, liquid carry under or gas blow by can also be a problem that can happen. Or emotion issues can also come up when you're looking at your surface facility. What do you do for optimization in this case scenario when you have issues like this in the surface facilities? How are you going to optimize production there? By designing the separator, let it is the design of the separator be such that there's enough settling time there, which is your retention time. Ensure that there's sufficient settling time there. Then also make use of chemicals for these emotions issues by use of defoamers or demulsifier. Then you maintain mist pad and plate track. You look at the internal of your separator. Okay. Then this is another aspect of our production that ought to be what optimized, especially in Niger Delta area where our crude oil are mostly paraffinic and water rich. So we're always going to, most times, flow assurance problems arises in most of our crudes. And if you look at optimizing production and papers that have been written, especially in the Niger Delta region, you're going to have papers such issues such as hydrate formation, wax deposition. It's because of the kind of fluid that we produce in the Niger Delta. They are mostly paraffinic and water rich. So issues like wax, hydrate management now becomes what important to us. So it's not when you're designing and you say you want to optimize production, you must take into cognizance that these things would prevent fluids from moving from reservoir to the market. So how do you mitigate these problems? How do you mitigate them? You can carry out thermal insulation and electrical heating of the fluids, or you can use chemicals now by bringing in chemical inhibitors into your fluid, mechanical use of pigging, which is regular cleaning of your system, then design of your pipeline. You do pipe in pipe area, or optimize routing of your fluids. Now, when we are looking at our export now, when we are talking about processing and export, which is like saying this is the height of everything, because we said from reservoir to export. So export should not be out of it. So yes, I've produced my fluids, I've separated, but then what type of fluid am I selling to the market? If I'm not able to balance the product I'm sending out, I've broken one of the chains. And I said optimization means balancing all the systems of production. So I want to look at my sale quality specification. We already know that our BSW should be less than 0.5%. You look at your reed vapor pressure and ensure that it is vapor pressure limit for safety. Ensure that that is also up to specification. Ensure that there's no hydrogen sulfide in your crude or in your gas. There's no CO2 excess of heat. You carry out dehydration of your gas, sweetening of your crude. These are things that you must do to ensure that your sale meets what specification, quality specification. Also, when you talk about physical metering, the cash register, you must be able to ensure that accuracy is there where there's ownership transfer. When I'm selling or moving my product from one point to the other, I want to ensure that what I recorded that was moved is what is actually there. Our measurement tools has to be ultrasonic. We have to use some measurement tools when we are looking at loading of our products. So we have ultrasonic, Coriolis, high accuracy, and low maintenance. You must prove and ensure what calibration verification always. There's a little calculation here that tells you that even a 0.1% error on a 100,000 barrel per day of crude oil sold at $70 per barrel can actually cost you a lot of loss per day. So no kind of error should be allowed when you're doing your calibration. So ensure your measuring tools are well calibrated and verified. Then we come into what we now call our integrated optimization. How is it done recently? How has optimization been done? How is it being done now, especially for those in the field? So life is so easy now that I won't say so easy, but then these optimization tools are ensuring that things work smoothly. So we have a full system modeling where before you even come in, you've modeled everything. You can actually check to know. You don't have to go and face the problem first before you've anticipated a solution. So coupling reservoir, we have well-bore surface network. We have tools, like I said, software tools. Most times when we attend conferences, we see people that sponsor this training to learn these tools. We have Prosper, we have GAP, we have ICES. I think ICES usually, can't remember the two. Okay, facilities. Yeah, when we talk about ICES, ICES models our facility and try to simulate facilities. Why there's a pipe sim that is there, talks about pipeline hydraulic. These are some tools that are out there. Prosper nodal analysis are used to model our wells. Okay, then GAP is more of a network optimization tool. Then we have artificial lift optimization, where real-time surveillance of our tools and gas lifts are being used to prevent downtime and operate at peak efficiency. So these are ways we optimize production. You have digital oil field, which is leveraging on IoT sensors, IoT sensors now, which is Internet of Things. Yeah, there are sensors like that that are installed at the wellhead. They watch equipment performance, they track inventory, they collect data, they share real-time drilling parameters. These tools are all there right now to ensure that production goals is being optimized critically. We have machine learning for analytic, predictive maintenance. Then, okay, I've talked about digital oil field technologies, just like we can see here. This is SCADA production dashboard, and also having real-time monitoring is checking the well status, the flow rate trend, the pump efficiency, the system pressure. It reads everything from a real-time system. So you can actually monitor your production from the well, from the reservoir, or from the well borne, as the case may be, down towards surface operation. So all this is to enable proactive decision, mainly just to enable you to make real time, because like I said from beginning, if you want to optimize production, then you as an engineer have to make you have to make decisions, okay, critical engineering decisions, and all these tools are out there for you to make that kind of decision. So you're moving from reactive to proactive operation. There's real-time data, there's remote controlling, there's automated alarm, there are asset integrity that are there. So finally, let's remember these things. We think in systems and not in components. So in production, if you must optimize production operations, you think in systems and not components. So you're not thinking in isolation, because nothing is in isolation. They are all they are interdependent production systems from one to the other. Optimization is balance. We're not looking at maximum output of a particular system. So you're not going to tell me that, oh, this system is giving me maximum production, let me focus on it. No, it's a balance, not maximum output. Optimization is balance. And finally, engineering decisions involve trade-off. There's no free lunch. So every decision involves a compromise. You're looking at I-rate, you're looking at I-rate versus the reservoir demand, you're looking at CapEx versus OpEx, you're looking at short-term gain versus long-term recovery. So everything has to do with decision. There's no easy way out of it. So whatever decision you're making, you are balancing it out with a similar consequence. So that is why taking topics like this and learning about them even before we even get into field is very important, so as to prepare us as young engineers to start thinking critically, to start equipping ourselves with the necessary tools that are needed. When you have the opportunity to go for conferences, attend conferences, join chapters, read. When you join SP bodies or professional bodies like this, they give us talks. They equip us with the right information that we need. When you attend conferences, you hear of research people have done. When you read journals, people's research, especially One Petro, when you go to One Petro, all these our research domains, journal domains, you get to read real life research that is being done in this area of it. So you equip yourself with the right information to make these engineering decisions. And you can also get these skills. The internet has become so wide that you can learn a lot of these things. Before, most of these simulation or predictive tools were just restricted to data analysis and Excel. Most of our textbooks still use Excel to explain IPRO and VLP. But of now, these things, MBAL is there. We have different softwares that are out there. However expensive, but these are things that you can actually, when the opportunity presents itself, you take up these skills, you learn about them, you read journals, you equip yourself to make the right decisions, and you bring balance to the system and to the production industry. So with this, I said thank you for listening. I really appreciate it. Over to you. Okay, Mr. Anthony, yeah, I think that covers it.
Thank you very much, Ma. Moderator, please, over to you. All right. I don't know if the moderator can hear me, but in the absence of the moderator, we are going to be taking at least 3 questions. So please, if you have your question, you can drop it in the chat room, or you can raise up your hand and we will give you the floor to ask your question. It's question and answer time, so that our moderator can do our facilitator can do justice. Okay, I can see one hand. Aminu Mohammed, please go ahead. The floor is yours.
Thank you so much for taking your time to do this lecture for us. I'm Engineer Aminu Muhammad Eme, a field engineer at Irosati Firebot Limited. So please, my on here is not a question. I just want to know if either we can get this slide to our emails or something like that for our further readings and what have you.
Okay. Yes. The meeting or this session is recorded, so yeah, we can share it with you. Yeah, thank you very much.
Okay, thank you so much.
Sorry, I had a network issue. That was why I could not come in so quick.
All right, please go ahead, moderator. Yeah, thank you.
All right, thank you so much, Mr. Williams. Okay, fine. I know we've already started the question and answer, so please, we will not be wasting much time. I would just need like one question for the guest speaker, and we'll try to wrap it up for the day. So, any other question? The last question.
I think there is someone and that
Yes.
raised. I can't really get. Okay,
Yeah, I'm raising my
Elvis.
hand.
Elvis.
Yes.
Okay.
So Dr. Praise, thank you for the lectures and all that. It's quite insightful. Well, I want to ask a particular question. So from the supply chain perspective, what are the most critical items within the wellhead to export supply chain that, if delayed, can cause like a big operational impact? And what skills would someone need to fill in this gap? Sorry, please, did you get me? Hello?
So, okay, I want to believe you're asking that from looking at surface equipment now from the wellhead is where fleets move to, we now start talking about we want to export. So which of the chains now is important for supply not to be stopped? Do I get that correctly?
Yes, exactly.
Okay, and if there's a particular skill one can employ to ensure that there's no stop. So firstly, let's understand that except you're trying to do a test on your well, it's expected that at no point in the well is the well killed or closed off. But what we only do that stops that movement as it's coming from the reservoir down to our export is only maybe we are trying to build up pressure. So we shut the well for a period of time to carry out pressure build up, allow pressure to come up, then we can resume production again. So there's no point at which it stops. Rather, what we do is regulate flow, which is the choke on the Christmas tree there on our wellhead. We use that choke to regulate the flow. So
I guess she has answered your question.
Moderator, I think the speaker is still speaking. Maybe she's having a little network glitch. So let's
Okay,
just
all right.
hold on a little.
Understanding your choke management very well, and how you can actually understand your choke management, or how you can manage that, is actually by running some sensitivity tests, and these are done actually from your nodal analysis. So from the study of nodal analysis and actually some sensitivity tests, and even this Prosper software, you can be able to now decide what type of choke to use, what type of tubing that can be employed there to ensure that, okay, the volume of fluid I'm producing, my separator can actually handle it, or this choke size can actually handle it. So what we can do is manage the flow of fluid, not actually to stop it, except there's an emergency in the well. If there are other people that are in the industry, I believe they can share more light on that. But I believe this answered the question very well. Thank you.
All right, Engineer Praise, thank you so much. I know because to some point, my network was actually fluctuating, not really stable, but I'm still like fully in touch with everything that has been happening. Thank you so much, Engineer Praise, for that wonderful, remarkable and amazing, lecture you gave us. We have actually marked the March technical lecture. And I must say thank you so much, all of you who joined. And I really appreciate your efforts so far. You actually made this month a special one. And I want to also still, wish our Muslim brothers happy Eid Fitr. I know we are still in the celebration. So, and most of you might be in this, in this room, undermining that you were supposed to, have, your celebration still going. Thank you so much. Okay, right now, I will be having the presentation of certificate, and that will be, taken by Mr. Enore Joseph. Thank you. Hello, are you there with us, Mr. Joseph? Hello? Hello, can you hear me? Hello, William, are you there?
Okay, yeah.
Okay, can you
Since
on
Mr.
it?
Yeah, since Mr. Joseph is probably not available, I'll do this on his stead. So, on behalf of SPYP Technical and Career Team, we want to recognize and appreciate the presence of Engineer Praise Agbabi, who has done justice to this technical lecture program from wellhead to export, optimizing oil and gas production operations. So even from the chat box, we could see positive comments of how you took out time to explain this entire process for us in simple terms. You've helped us to walk through this pattern, navigate the entire journey of crude production to the process or to the export stage. So we really thank you, and we appreciate your effort. So on behalf of the YP Technical and Career Team, we present you this certificate, and we wish to have you more in upcoming programs. Thank you, man. Please, with the clapping ovation,
Thank you
let us
so
celebrate
much to the entire team. I'm really grateful for the opportunity and for this certificate. Thank you so much.
All right. Thank you so much for the presentation, William. And it's now time for the photograph section. So please, I would advise you to turn on your camera so that we can capture, our faces. Thank you. So please, wherever you are, just on your camera. All right. I don't know, I can see, please turn on your camera, please. All right, just try to turn it on. Okay. Everyone, I'm waiting. All right, please. Okay. All right. Are we ready? Ready? Okay. It's all right. I'm still waiting. I'm still waiting. Just try to turn on your camera so I could get a proper view. All right, thank you. And that's all. And that's all. Thank you for this section. And I feel I've gotten most of our faces. Thank you. All right. We are rounding it up now. Like I said, thank you so much for the executive who actually put these meetings together. And it was quite a wonderful one. And subsequent time.
Sorry, moderator, sorry, yeah. Hello, sorry, we have other activities here, so yeah, sorry
Okay.
about that. Yeah. So
all right.
yeah.
I didn't check that. We'll be having a SP awareness and upcoming events. So Jude will be the one to throw more light on it. Okay, the floor is open for you.
Good evening, everyone. Thanks to our technical presenter today for such a wonderful session. And so I'll be leading the SP awareness and upcoming events session today. So as you can see clearly on your screen, so it's more or less like an awareness for us to become a member of SP. So one thing is to attend our functions because of our virtual lectures, whether our physical lectures as well. Another thing is to become a registered member. So there are lots of opportunities that you stand to gain when you become a registered member. So you must have gone through as a student member and also then go into becoming a one professional or a full-fledged professional. So there's lots of advantages and also opportunities that exist when you're a registered member, opportunities to be able to have access to person who actually work in that sector, networking and collaborating with other young professionals as well, and also being able to volunteer, just like we are doing this session, to be able to help organize them. Amongst this as well, the benefits are numerous. So you can see the QR code is there. You can just scan. You can, in the comfort of your home, fill out the details to help to register you or to renew your membership if you're already a member of the SP. We also have other events that are lined up for the months. As you all know, we have our Student Technical Symposium and Education coming up from 26th to 28th of March at the TI Conference Center. Promises to be very exciting. We have loads of good sessions, mainly technical sessions, panel sessions, sessions, moving the physical basis to telephone and be present. We also have other activities lined up for also preparing for our technical symposium and something. That's like how to the activities. Yeah, moderator.
All right. The closing remark will be going to Janet Ade Sujo. Okay, please give us the closing remark and voice of thanks.
All right. Thank you very much for the opportunity. Good evening, everyone. As we wrap up today's session, I'd like to sincerely thank our facilitator, Dr. Praise Agbavi, for our insightful presentation on from wellhead to export, optimizing oil and gas production operations. Despite the fact that there's some network glitches, I'm very sure, because I learned a lot from this session, and I'm very sure that people have learned one or two things from this session. They have one or two take-homes from this session. Thank you very much, ma'am, for the session. And I also like to appreciate the Society of Petroleum Engineers, SPD, and also particularly the SP session, Warby session 104, for organizing this impactful session. For everyone who joined us, thank you for your time and also for your patience throughout the network glitches. and your participation. Thank you very much. We hope to see you in our next session. Have very much.
I guess we are done with the section. Here, everybody has said a lot, even down to, William, to Joseph, which was kind of, represented by Williams also. A lot of persons, they've said a lot about how it went today. And I want to thank everyone, most especially, the team, the YP family, Lucky Amiemie, to the co-chair, Mr. Nelson, to everyone who has shown concern. And also, I could still identify that our secretariat is right here with us too. Another person than Mrs. Tessie. We do call her Madam Tessie. Thank you so much for showing concern to still be part of this event. Every one of you, thank you. Our guest speaker, thank you. Section chair, wherever you are, thank you so much, and your family. We wish you a wonderful celebration, because right now the Muslims are celebrating, and we also wish you a wonderful, ending of the match, and we pray that whatever you are aspiring, would definitely come to you. Wish you well. Thank you so much for joining.